We did part A and we found the pressure exerted by the oil on the base of the tank. We know that beta liquid pressure is found using the formula rho GH or DGH, density times a gravitational field strength times height or depth of the liquid, right? So we just calculated that, which turned out to be 12,750 pascals. Now the force exerted by the oil on the base of the tank. Now beta, we know what pressure the oil exerts on the base, so we can find the pressure force. Now with this formula, force is equal to pressure times area, right? Right beta? Because you remember this pressure force time area, this the formula triangle, right beta? Force divided by area is equal to pressure. So force is equal to pressure times area, right or wrong beta? We use the value of the pressure, we calculated an area, we were given the dimensions of the base um, uh, of the oil tank. So beta, its base is rectangular, so area for rectangle is length times width, so we just multiplied length and width and we got the area, and that's how we found the force, which was 45,900 newtons. Done beta. Now the force calculated in A2 is the weight of the oil. Calculate the mass of the oil in the tank.
Mass is equals
Beta,
to
how can we
weight
calculate
divided
mass?
by
Ji beta?
sir, mass is equals to weight divided by acceleration of free fall.
G M is equal to W divided by
G.
G. So
And
beta, it's 45,910. So cancel. So it will be
45.
4,590 kilograms. Okay beta, units are very important, and beta working is very important, and sometimes find that students they directly write the answers. So beta, please write formula working and then the answer, please. Okay, and do not forget to write the correct unit. Okay beta, when he is checking the level of oil in the tank, a man drops a brass key into the oil and it sinks into the bottom of the oil. State what this shows about the density of brass.
Sir,
So
its
beta, what
density is greater than.
shabash. So beta, the density of the brass density of brass is greater than density of is greater than the density of
Oil.
oil. Okay. Explain how attaching the key to a piece of wood could prevent the key from sinking. Better we attach the key to a wood, then that will not sink. How can we explain this? Shabash, can anyone explain this? Abdul, can you explain this?
So the density of wood is also greater. So
Abdul Rafi,
it's
ji beta?
sir, because wood is less dense than water.
Wood is
Less dense than water.
less than water. Beta, first of all,
No.
Rafi C. Rafi C. Beta, first of all, okay, wood is less dense than water. We know that, beta. But here in the question, what are we discussing? Oil or water? See.
Oil.
So, beta, many students make these mistakes. Do you have to read the question? Why would you say water here? Because we are explain how attaching the key to would prevent the key from sinking into what oil. So we have to compare the density of the oil with them, na? Not the water. Understand?
Yes, sir.
So, beta,
Wood is
please
less.
read the question carefully. and then answer accordingly. Now beta, this happens is when the when we attach a wood, the combined density of wood and brass, or you can say of wood and key, shabash, their combined density is less than the
density of oil.
density of जी beta,
Oil.
density of oil. Okay, so that's why that will not sync now. So the beta combined density
Sir, but how is it less? Because brass density is greater than oil, so if we add
but
more, so it should be.
beta, but we are attaching it to wood, and the density of wood is less than the oil. Okay, so it is so much less than when we combined, we take the average density. Okay, so that is less than the density of oil. Okay, or you can say density of wood plus key is less than the density of oil. Okay, beta, got it or not?
Yes, sir.
Okay.
Yes, sir, got it, sir.
Next, beta, a manometer containing a liquid X. You remember, beta, we studied about manometer? Beta, simple manometer is used to find the gas difference in pressure, right? Or pressure difference, right? And beta, simply you have to remember the height difference between the levels of the liquid that gives the pressure difference. Right or wrong?
Right, sir.
Do you remember, beta, we discussed that the pressure here in this case, first of all, tell me which pressure is greater, gas pressure is greater or atmospheric pressure is greater?
Yes.
Sir, gas pressure.
Okay, so here gas pressure is basically equal to atmospheric pressure plus pressure due to the liquid column H, right? And how can we find the pressure due to the liquid column H? We can find it using the formula rho GH, right?
Yes, sir.
So better see, this is how we're doing. So when there is a like a topic, I shortly or briefly revise about that topic. So all the things we have studied that come to your mind. So better now you recall all the things related to manometer. You remember that or not?
Yes, sir.
Okay. Beta, atmospheric pressure is given. It's 9.9 times 10 to the power 4 Pascal. The height H is 0.36 meter. The density of liquid X is 8,400, 8,400, sorry, 840 kilogram per cubic meter. Calculate the pressure due to column of liquid X of height 0.36 meter. Beta, how would we calculate the pressure due to column of liquid X of height 0.36 meter? How would we calculate that? Shabash, who will tell me? Raise your hand. We did a similar question like that. Okay, so beta Abdullah Subhan, please can you tell me how would we find the pressure? Abdullah Subhan, beta, hurry up, we don't have time. Shabash, beta.
Yes, sir.
Shabash, beta.
Sir, can you hear me?
Ji, beta, can I what?
Sir, can you hear me?
Yeah, I can hear you now. Abdullah, beta.
Sir, we will divide the height with density.
We'll divide the height.
Sir, rho GH.
Wait a second, beta, Noor, wait. Abdullah Subhan, beta, how we find the pressure due to liquid column? Beta, did we not do it? What does it mean,
Sir,
divide the height with? Beta,
MGH.
are you even paying attention? I just, in the previous question we just did that how we find the liquid pressure. pressure exerted by the oil on the base of the tank. How do we find that?
Rho H.
So beta, is it that hard? I mean, you are not paying attention to the class at all. Beta, exams are on head. What is this attitude? Pressure due to a column of liquid X of height 0.36 meter. We know that pressure is equal to G Abdullah Subhan beta. Pressure is equal to G beta Abdullah.
Sir, will multiply.
Yeah.
Sir, will multiply.
G beta. Sorry, I'm unable to understand what you're saying.
He
we
said
will
we
multiply.
will multiply.
Beta, what we will multiply now? You have to tell that. What is the formula for calculating liquid pressure?
Sir, density into gravity into height.
Shabash. Okay. So it's density times gravitational field strength or acceleration of free fall G times height. Okay. So beta, what is the density of the liquid?
Sir, 840.
Shabash. Liquid X has the density of 840 times value of G 10 H is 0.36. Now beta, if you multiply this beta Abdullah Subhan Shabash, multiply them and tell me what you get.
3024.
G beta
2024.
24 times. Is that the answer?
Sir, it's 3024.
3020.
24.
Okay. So beta, we get the answer. The answer is 3024 Pascal, right? So beta, you can write it as is, or you can also write that in the exponent form if you want. Right, beta? So it's fine, or you can write it as is this 3.0 times 10 to the power 2, 3 times 10 to the power
4.
3.
3. It is if this weight is coming 3, so beta times 10 to the power 3 if you want, right? Both are fine. You can do it anyway, or you can also write 3.024 times 10 to the power 3.024 times 10 to the power 3 Pascal. Okay. The beta pressure of the gas supply. Now, what is the pressure of the gas supply?
So 9.9 into 10 power 4 minus 3.
Why minus, beta? Why minus? See, gas pressure is equal to atmospheric pressure plus pressure due to column.
Height.
Yeah,
H.
pressure due to liquid column of
X.
liquid X of height H, which is given, right? So then it will be not subtraction, but it will be basically addition.
Okay, sir.
9.9 times 10 to the power 4 plus 3024. Shabash. When you add this one, do you get?
Sir, 102,024.
100,
2024. 24.
102,024. Right?
24.
Right? Pascal?
Yes, sir.
Or beta, if you want to, well, it's better write 3.024. Okay, or beta, you can convert that into the exponent form or standard form. Then 1, 2, 3, 4, 5. What can you write? 1.0, or you can write 1.02. It's up to you. 1.0 times 10 to the power 5 Pascal. So you can also write it this way. Beta, got it?
Yes,
The
sir.
pressure of the gas supply stays constant. Beta gas supply pressure of the gas supply does not change. Okay. Describe what happens to the liquid levels when. Now this is important and tricky questions. Okay. This describe what happens to the liquid levels when the liquid X is replaced by the same volume of a liquid of greater density. Now this liquid X is replaced by with the same volume by the same volume of the liquid of greater density. Shabash. Now beta same volume of the liquid density means this first of all this gas pressure stays same, right? Right or wrong, beta? Now X is replaced
Yes.
by the same volume. Volume of the liquid is same but of greater density. If we use same volume of the liquid with greater density, then beta what will happen? The same height will result into beta the same volume of the liquid when poured into in this tube, then beta what will happen?
Sir, the liquid
Shabash.
levels, it will be down, and
Ji beta which will be down?
sir, the left side.
Sir, H.
Okay.
Sir, it will increase.
Left side will go down.
Yes.
Beta basically see when more dense liquid is used, beta this height difference, the height difference, what will happen to that?
Sir, it
It will
decrease.
Increase.
because the pressure difference is same, na?
Yes.
Gas pressure does not change, atmospheric pressure is there, it does not change, right? So if you are using a liquid which is denser than the liquid X, then obviously the same difference in pressure difference we just calculated here. It's what is the pressure difference? Okay, pressure due to liquid column X is 0.36 meter, right? So basically the pressure difference is given by 3024 Pascal. Clear? Now beta if you use if for a denser liquid, if you use a denser liquid, the same pressure would be caused by less depth, right or no?
Right, sir.
Beta, for example, here, let me give you example. There are two different liquids, okay? Okay, in the same container. But it's important to understand this concept. This is very important and a bit tricky concept, okay? So, beta two containers, okay? Now, beta this liquid A and liquid B. Beta liquid A is more dense, okay? Beta, you remember we studied in the properties of the liquid that beta liquid pressure increases with depth. At any particular depth, pressure acts equally in all directions, right? Pressure does not depend upon the shape of the container, right, beta? And pressure also depends upon the density of the liquid, right or wrong? Right or
Yes,
wrong,
sir.
beta? Now, beta, these are two liquids A and B. Now, beta, we got 2 points at the same depth. Point A here, let's say this is point. I call it point P, and beta another point Q. See, beta they are at the same depth in the liquid level. Both the liquid they are at the same depth, right? But beta liquid A is more dense than the liquid B. Then beta which point will be at higher pressure? On which point there will be higher pressure?
Sir, P.
E.
Point P because liquid A is at greater depth, right? Now beta if we just change it, now beta the same pressure if we have to put this both the points at the same pressure, let's say now the same liquid, so now beta this point P is at this point. Now beta there is certain pressure on point P. Now beta if we want the same pressure in the liquid B, so then tell me that at what depth that point should be. Should it be above this level or below this level or at the same level?
Below the level.
below the level. Shabash. So beta, now let's say this is point Q here, and now beta see the same pressure will be caused by greater depth. Getting my point to note? When so beta, if the liquid is dense, more dense, then the same pressure would be caused by less you can say height or depth. Getting my point to note?
Yes.
So beta, when we first of all, you should know that when we use a liquid which is more dense, then beta the H will be smaller. Okay, beta, I think the time is almost over of the class, right?
Yes, sir.
Yes, sir.
Okay, and beta, actually, I wanted to make an announcement, so that's why I'm gonna hold on here in a moment, and then we'll beta. I'm thinking of having a test of chapter number 13, 14, and 15, which are very easy topics. This is just energy transfer, and beta sources of energy like renewable and non-renewable energy sources. And beta, the old topic basically, this is all three chapters are interlinked, and sometimes the questions are also asked combined. So that's why I'm saying that you prepare these three chapters for a test, and you tell when do you want to have a test. We have a next class on Wednesday and Thursday, so you can pick any day.
Sir, Wednesday. Wednesday.
Sir, Thursday.
Wednesday.
But you decide. Okay, just now raise your hands who want the test to be on Wednesday. Raise your hands. We see how many hands raised. Two only.
Sir, we have a test on Thursday of maths.
Yes,
You
sir.
have test on Thursday of maths.
Thursday. So
Sir,
Wednesday.
Thursday is easy.
Beta, it's up to you. I don't want to burden you, but whatever you say. You have only one test of math on Thursday.
Yes, sir.
Yes, sir.
It's
Yes,
very
sir.
small.
Now it's up to you. Five students want to have test on Wednesday, and beta, how many students want to have test on Thursday? Okay, I think there are many students who want to have test on Thursday. So better
Sir,
than
some don't want the test.
G beta,
Some don't want the test.
G beta.
So, I'm saying some people don't want the test.
Some people they didn't raise their hand, but that was not the option. So either the option was either on Wednesday or Thursday. So beta, is it okay that we will have test on Thursday?
Yes, sir.
Beta, now
Sir,
14 students. G beta.
sir, for Wednesday there are 8 hands and for Thursday there are only 7.
For Wednesday there are 8 hands.
Sir, 5.
Beta, I think there were
There are only
five.
5.
You do not have any test on Wednesday?
No, sir.
No, sir.
Oh, okay then, beta. Wednesday. Fine.
So, chapter 13, 14, 15.
Chapter 13, 14, and 15 test on Wednesday.
Okay, sir.
Is that
Okay,
clear to
sir.
everyone?
Yes, sir.
Beta,
Clear, sir.
there are 14 students in the class. Okay, so how many are not present in the class? Or is everyone present?
Sir, 4 are not present.
Okay, but I think I will also message this in the group. Okay, so the students who are not even present, they know that. So beta, I think the time is up now. So then beta will continue with the worksheet. In next class we will have test, and after the test we will continue this worksheet. Okay, beta.
Okay, sir. Allah Hafiz, sir.
Okay, beta. Allah Hafiz. Have a nice day.